Hello, students. Let's go back to some of the very first things that we did in Python. We added numbers, we subtracted numbers, we multiplied numbers, we took them to powers, and we used these operators in order to do it. But really, these are like functions, right? I mean, we write it slightly differently, 3 plus 4, and we get an output 7, but this is just like having a function that takes in two numbers and adds them. Now, we could always come up with our own function, add 2ab, and return a plus b if we wanted this in function form. The advantage to having a function is you can do all sorts of things with functions. You can pass functions to functions and hand them around. We might want to add as a function. Okay, well, this will work. Add 2, 3, 4, and you'll see I get 7. However, we don't need to do this. What we can do is go into the operator library. So import add. And this will give us addition as a function. So let's just check that, 3 and 4, and I get 7. Okay. Well, what's in this operator library? How do I know which things, we have functions for and which we don't? Well, let's look at the kind of things we were just doing to integers, right? We'll do a little directory here, right? So you'll notice that we have the name add here, just like we have the name mul, the name pow. So this is giving me hints as to what might be in the operator library. Of course, you could just do a Google search, what's in the operator library. But let's try to grab some of these. Sub, that might be subtraction, and see what they're doing. So from operator import, let's do mul, sub, and power. We'll wait on division because division's a little weird. So let's try mul 3, 4. That should give me 3 times 4. Sub 3, 4, 3 minus 4. And pow 3, 4, 3 to the 4th power, which is 9 squared or 81. So those are working nicely. Let's try grabbing division now. Now, if we want to avoid floats, we actually need floor div, which we can find over here. Floor div, which is like dividing and rounding down because you're saving room for the remainder. And we will grab mod because that's our remainder. So if I wanted, say, 7 divided by 3, which would be 2 with a remainder of 1, I can get this by taking floor div 7, 3 and mod 7, 3. And that gives me 2 with a remainder of 1 as well. What other sorts of things do we have in the operator library? We have neg. Let's from operator import neg. And all this does is, it's just like if you have the number 6, there's an operator where if you put a minus sign in front of anything, even if, I'll put this in parentheses to show you that I'm not entering the integer -6, right? I'm taking the negative of whatever this integer is. That's an operator. It takes in a single thing and outputs a single thing, but it's still going to be an operator. So let's try it. Advanced Python, we're going to take the negative of 6. Okay, so those are some things in the operator library. What other things do we have, say, numbers on either side of? Well, stuff like that, 4 less than 5. And it turns out that 4 less than 5 is true. Maybe we want this as a function that spits out true or false. Well, from operator import. So I'm just going to import less than or equal, greater than or equal. And then let's import equals and not equals. And we can try those. So instead of saying, hey, 4 is less than 5, I can do less than 4, 5 and get true. If I do less than 4, I'm going to get false because 4 is not less than 4. But if I go less than or equal to 4, that's going to be true. And what other ones do we have? Well, is 4 equal to 4? We could check that. Sure, equality. And we could use this, you know, as a replacement for our double equality sign that we're using all the time with other things too. For instance, if I want to check if sets are equal, 1, 2, and 2, 1. Are these equal as sets? Well, they should be equal as sets because they contain the same objects. Or if I wanted to check about repetition, 1, 1, 1, and the set 1, are these equal? Sure. So basically, if you don't like the double equal sign, you can always use EQ from the operator library. And then there's not equal, right? We could check this for lists. Is the list 1, 1, 1 going to be equal to 1? So that should return true because they're not equal. Or if I were to write equal here, EQ, then this should return false. So that returns false.